Okay, so good morning everyone. Magandang umaga, hapon, o gabi sa inyo. Ako si Seth Maneza and today we will be talking about circular motion. What is circular motion? How do we solve circular motion? What are the units of circular motion? And all that. Now, first things first, circular motion is the movement of an object along the circular circumference of a circle or rotation along a circular arc. Now, what does this mean? As you can see from the image below, so credits to 123RF for helping me provide this picture for you guys to understand it more better. So in here, the car is moving or rotating along a circular arc. What is a circular arc? It's like this, circular arc. Circular arc. It's like that. Now, as we can see in the problem stated here, a car is moving at a constant speed of 20 meters per second around a circular track with a radius of 50 meters. So the 20 meters per second provided here, that is the velocity. Therefore, V is equal to 20 meters per second. And it is moving at a constant speed of 20 meters per second around a circular track with a radius of 50 meters. It's the radius. The 50 meters is the radius. Therefore, R, which is the symbol for radius, is equal to 50 meters. Now, the question is, what is the car's centripetal acceleration and what is the net force required to keep the car in a circular motion if its mass is 1,000 kilograms? First things first, since we are finding what is the centripetal acceleration, we can use the formula of AC is equal to V2 over R. That's the formula we will be using in order to find the centripetal acceleration. But first things first, we're going to identify what are the givens in order for us to know what to substitute. Now, so please excuse me for my bad handwriting because I can't really do much about that. So first things first, as I said here, it's the velocity, which is the 20 meters per second. Givens, yes. So V is equal to 20 meters per second and the R is 50 meters. Now, the question states that what is the centripetal acceleration? Now, we will be also including that in our given since that's what we're going to find. There you go. And for the question number 2, it provided a mass, which is 1,000 kilogram. Mass is 1,000 kilogram. That's a pretty heavy car. And it also stated what is the net force. So we're going to find the net force, which is also the centripetal force with the symbol of Fc. There you go. What is that? Now, to solve number 1, we're going to need to use this formula. Now, since we have a velocity already and a radius, we're just going to substitute that. So the velocity is 20 meters per second squared, since it has squared right here. Oh, I'm sorry. And the radius is 50 meters. Now we're just going to multiply it by itself and double the units, since that's how you square a unit and a digit. Now, 20 meters per second squared is 400. meters squared, since I stated earlier that we will be doubling the units also. There you go. Now, there won't be much of a change within the radius. Now, after that, we're going to cancel the units, which is the meters, and we will only be left off with only one unit, which is only a meter, not meters squared. Now that we have that, we're going to divide, since there is a fraction bar. We're going to divide, which is 8. 400 divided by 50 is 8. Now, we substitute the units, which is meters per second squared. Now, why is it that still remaining squared and the meters has changed? It's because the unit of radius is meters and not meters per second. Therefore, there won't be any seconds to cancel the seconds here, if you get what I mean. Now that we have, now that we have the acceleration, we are done with the question number 1, since this is the centripetal acceleration. We're done with that. Now, moving on to number 2. For number 2, which is the centripetal force, we'll be using the formula Fc is equal to mass times the centripetal acceleration, which makes sense since in the question number 1, we took time to find the centripetal acceleration, which will be very important for solving the centripetal force. Now, since we have our centripetal acceleration and we have our mass, we will be substituting the values. So we'll be putting these here. Going back, we substitute the mass and we substitute the acceleration, which is the 8 meters per second squared. Then, we won't be canceling anything since there is no common units. We will just multiply since they're both in a parenthesis, which we will get 8,000 kilogram meters per second squared, or 8,000 newtons. Why Newton? Since kilogram meters per second squared is also the same as Newton. And why is that? That's for you to answer in the comment section below. Now, what is the differences of these units? Now, for velocity, the units are meters per second. That's velocity. For acceleration, the units are meters per second squared. That's the units. For radius, the units will be meters. And for mass, the units will be grams or kilograms. That's how you distinguish the values. And for force, it's Newton. And that's it. Now you know how to distinguish the values, how to distinguish the formula and to substitute the values, and how to solve centripetal acceleration and the net force. Now, what does this mean? Why are we all doing this? So, to explain, the centripetal acceleration always points towards the center of the circular path. It does not change the car's speed, only its direction. And the centripetal force, which is the 8,000 Newton, is provided by friction between the tires and the road. If this force is insufficient, like the road is wet, the car may skid outward. Like outward. Or I don't know, pag ganito. Basta aalis siya sa circular path. If the car increase naman yung speed, if nag-increase naman yan, no, the required force will also increase. No? Mag-increase din to. Since mag-increase to. Since nag-increase to. Diba? Pag nag-increase yan, mag-increase din yung required force. Yung acceleration, mag-increase din. And if the radius naman is increased, the required force will decrease, making it wider turns easier for vehicles. Bababa naman to. Bababa yung mga yan. Bababa yung radius. Ay, hindi. Pag tumaas pala yung radius. Pag tumaas yung radius, bababa to. Bababa to. Bababa to. It will decrease. So I hope you get it. And that is all for circular motion for today. This has been Seth Waneza with your weather updates. Hindi, joke lang. That's all, Teacher Waneza. If you have any concerns about my teaching skills or within my formulas or whatever, or how I solve this, feel free to comment and enlighten me down below. Thank you.